So let's do the demonstration. And the demonstration today, I will be using black marlin. So let's go hook a big fish, all right? So this is MSC Apex Modeler, and when you come into the product, remember I've already emphasized learnability of the product. So when you come into the product, there's actually going to be a library of videos that we deliver with the product, okay? I've lost count, to be honest with you. There's about 100 videos, maybe a few more. We're delivering these videos in English, Japanese, and Chinese, so that's something that actually MSC is proud of. So you can actually peruse to a topic of interest and watch a video if you want to learn in that manner. Normally what I tell people when they're getting started is I actually say go up to the search area in the product and type in the word tutorial. If you type in the word tutorial, then it takes you to a page that gives you a link to some getting started videos. And these are the videos that people who have been trained have used to learn the product. So there are 7 or 8 videos. We also include a link to the geometry that's used in the video so that you can follow along at home if you want to. Additionally, speaking of learnability, you may actually, as you're using the product, you may have a question. If you hover over any particular tool, it'll actually give you a graphic about what that tool does. There's also a link to text documentation and a link to a video specifically related to this particular tool. These videos are 1 to 2 minutes long to kind of just help you take a quick deep dive on this particular feature, on this particular function, and answer any question that you may have about how it should be applied in your particular scenario. Additionally, all the different tools have something we call workflow instructions, and the workflow instructions will basically say step 1, step 2, this is how you use this function, and they'll also give you some hints as to some keyboard shortcuts that might be beneficial while using this particular function. Okay? So let's get started, and what we're going to do today is we're actually going to do a mid-surface model of a aerospace bulkhead, and we're going to do a couple of other things as well, but we're going to start out here. I'm not going to do this entire bulkhead in the interest of time. We're just going to do a subset of it, so let's just take our subset here and kind of zoom in on it. This is actually one of the training videos that's provided with the product, and if you've ever seen me demonstrate the product before, you may have seen me use this part as well. It's a very good part. It has a lot of different salient features that I like to talk about in terms of MSC Apex, and I can bring those to light fairly quickly using this particular geometry. So let's get started. Our first step is to notice that there's actually a lot of different thicknesses here. There's lots of different fillets, and we have some powerful defeaturing tools, but I want to also emphasize that in addition to being able to defeature, we can actually work with the geometry as is if needed. Our edge and vertex drag tools are strong enough that you don't honestly have to defeature before you do it. So I'm going to just ignore that for the moment. And because there's lots of different thicknesses and lots of things that are intersecting, it's usually quite difficult to get an automatic mid-surface. So we're sort of going to manually make this mid-surface by extracting a few surfaces, a few key surfaces, and then connecting those together. So we're going to start out using what we call an auto offset tool. The auto offset tool allows us to offset a face of the solid. It automatically looks for the closest opposing face and offsets half that distance. Now in this case, it found the closest face, a shortest distance down here. I really wanted it at the middle of this thick section up here though. That's not a problem. I'll use these little graphical glyphs, these little balls. We call that the mid-surface manipulator. I'll just grab one of those balls and I'll just simply move it. By moving the mid-surface manipulator, it also moved the mid-surface. The mid-surface manipulator also makes it easier to go to an inner mold line representation, outer mold line, or back to the center, or I can type in any dimension that I might want, okay, if I actually know that I need it somewhere. So that's my first surface. I'm going to do a second surface. When I do this second surface, because there's different thicknesses and different offsets, these two guys actually don't show up on a common plane. Now, I know there's many. If I give a mid-surface model to 10 different people, I'm probably going to get 10 different representations. So I know a lot of people would want to keep this step in there. For my purposes, though, I actually want to eliminate that. So I'm actually just simply going to quickly align those two surfaces. And now they're in a common plane. Okay? So let's go back to my solid and let's extract a few additional surfaces. I'll do the web, and I'll do a start surface for this back flange. And this back flange has actually got a lot going on. There's quite a few thicknesses, quite a few steps, and I'm going to choose that one as my seed surface to do the back flange. There's another flange here, and I'm going to ignore it for the moment. I'm just going to forget about it, because anytime I've done work, one of two things is sure to happen. One, I'm going to forget something, okay? And if I forget something, I then have to fix it later. So this is going to represent what I have forgotten. This could also represent the change that we know is coming. It always comes. We know change is coming. So this is going to represent that as well. So this is the oops moment, or the oh my goodness, we got to make a change moment, all right? So those are going to be my starting surfaces. And one thing to notice, we've talked a lot about these smart tools. I want you to actually kind of keep count of how many tools that I've used during the demonstration. It's kind of a fun little thing as we go along. So I've used a mid-surface tool to get some seed surfaces. Now we're going to use the tool that we're going to spend the most time using when we're working with surfaces in MSC Apex Modeler, and that's the Vertex Edge Drag tool. Okay, so what I want to do is I want to connect this green surface with this other green surface. I'm going to do that by simply dragging this edge across, okay, and I'm just simply going to camp out on this surface. And I want to point out a couple of things here. One, I get a lot of feedback at the mouse cursor. It's telling me that if I release it, it's going to snap to that surface. If I hover over this edge, it tells me that if I release it, it's going to snap to that edge. I also get some dotted white lines that are showing me what the adjacent edges are doing, those edges that were adjacent to the one I'm dragging. So I get a lot of feedback, and I know a priori, I know before the fact what's going to happen when I let go. So I'm going to let go. It automatically snaps, it automatically stitches, and effectively red lines means it's a free edge. But yellow or green lines means that I'm actually congruent, and I'll get a congruent finite element mesh there. So let's now drag this edge, and we're going to drag it down to one of the faces of the solid. Notice that face highlights. That lets me know I'm snapping into that face. Notice how it automatically trimmed here. Didn't trim out the hole. That's going to be an enhancement coming soon. I'm going to clip the hole by just simply doing a quick trim operation at these edges to get rid of the hole. So let's delete that, and it's gone. Now I'll just simply want to take this upper edge here, and I'm going to drag it up to this face. I watch the face highlight. That's how I know it extended a little bit past because there's an extra height on the solid back here. I'll just simply take this edge and I'll drag it down. All right, so we've quickly made the back flange in just a couple of operations. A lot of times when you're doing a mid-surface model, you'll get these little slivers, okay, because you're offsetting to maybe a half distance. It's very easy to get rid of the sliver. Just simply drag the edge and move it over, okay? So a couple of things before I continue. I want you to actually notice that I'm doing a lot with one tool. That Edge and Vertex Drag tool does an awful lot. So I spend very little mouse miles going back and forth, back and forth. I can just stay in the one tool, and I can do a lot of work. Another thing I want you to actually imagine as well is that in my example here, I'm actually creating a mid-surface model from some seed surfaces. If that's not your challenge, maybe your challenge is dirty geometry. Maybe it's surfaces that have gaps and overlaps and slivers and such. Well, this is a pretty good example of that as well. So the same operations that I'm doing here would be the same operations you would do to clean up dirty surface geometry. So I want to close the gap in here between these surfaces, and I'm going to start that process by taking this vertex and I'm dragging it over. And I'm going to connect it to this edge. Notice that out in front of the vertex, there's a dotted blue line. Let me actually zoom in a little more. Maybe it'll show up better. There's a dotted blue line. That's a guideline. The guidelines are there to let me know when I'm tangent, when I'm perpendicular, when I'm actually following the tangent of that edge that's connected to that vertex. Now I'm simply going to move this edge to this edge. And I just watch what highlights. It highlights that edge. It did it. And I got one more little gap here, so let's close that. So we've now completed that side flange there. Now we need to actually connect the web into Now we have to connect the web to the two flanges. And I can easily do that with my edge and vertex drag tool. I can just simply drag these guys over. A couple of points here. One, I'm going to undo. So we have multiple undos in this product. A quick point about the drag. When you're dragging, you're basically dragging within the curvature of the surface that you're dragging. In this case, it's flat, so I'm dragging it in a flat manner. I can bend it. I can say, you know what, I want to connect to this edge up here, and that'll totally bend the surface. That's not what I want to do in this case, but I can bend it if I want to. Now, in many of these mid-surfacing scenarios, you may have a lot of surfaces that need edges to be drugged. You may have sort of a waffle-looking structure with ribs, and you want to connect a bunch of ribs together. So we have a really nice automatic surface extend tool that will allow me to select all my surfaces, and it'll do the extension automatically in that case. So if you have a bunch, you don't actually have to do them one at a time. All right, so let's now continue. We've got to work on the web just a little bit more. If I bring my solid back, I can see there's a little bit of a void there, and I need to fill that void. Let's do that a couple of different ways. We're going to be using the edge and vertex drag tool. I'll start by dragging that vertex there. I've still got just a little bit more to go. All right, so let's finish this up. And I'm actually going to illustrate a couple of different ways to do this. One way is to take this vertex and drag it over. And I can do this, and notice the guidelines that just pop up here. The guidelines that pop up. Those guidelines are letting me know that I am tangent to those adjacent edges. And notice how it just snaps when I get to that intersection location. So those guidelines effectively replace a lot of the construction geometry that you might create in traditional tools. Rather than having to jump through some hoops to get a point out there, I simply drug a point, use the guidelines to find out that I'm at the intersection of those adjacent lines. In addition to dragging that vertex, I can also drag this edge. By default, the edge drag behavior is called follow, which means the adjacent edges follow until they connect at that point. There's a couple of other edge drag behaviors that aren't useful in this scenario, but might be useful in other scenarios. There's what we call a stretch behavior, where the adjacent edges actually are changing their length. And there's also an extrude behavior, where I'm effectively creating new edges. So we'll go back to the follow, and we'll finish that up. Now, in my example here, I've actually got different thickness areas, okay, because I've got some fillets on the web section and the back flange. So let's actually introduce some splits to capture that. So I'm going to split the web, and I'm going to split the web at this guy, this guy, this guy, and there'll be a couple on the front. I'll do this guy and this guy. Notice that I didn't select the little round part. I'm doing some idealization here, all right? So this edge here, when it splits, it's not going to go all the way to that one, and that's not a big deal. Because once I get the split in place, I can actually do a vertex drag. And let's change the color here. Use maybe a slightly lighter green color. I'll just simply use the edge and vertex drag, and I'll watch the guideline. There's a dotted blue guideline here. It'll show up better on this one. There's a dotted blue guideline that lets me know that I'm actually extending that edge rather than deviating from where that edge is. And there's actually a little small sliver down here as well. Once again, follow that guideline, watch the edge that highlights. I know a priori what's going to happen before I let go of the mouse. Now let's do a split on the back flange here. So I'll pick those two surfaces, and I'll do the split at this particular edge, and I'll do the split at this particular edge. And I need to do a quick extension here, so I'll do the edge and vertex drag. For those that are keeping score at home, I've used 3 tools to do all the work that I have done. I've used the mid-surface tool, I've used the edge and vertex drag tool, and I've used the split tool. So I've done an awful lot of work with just 3 tools. So let's now go into the meshing operation, and we're going to mesh the surfaces. Now, in terms of meshing, we can do triangles and quads, all triangles. We have free meshing methods like the paver. We have mapped meshing for, more regular regions. I can mesh the entire body, or I can actually mesh individual faces, and I can use different mesh conditions for each individual face if that's what I want to do. In this scenario, I'm just going to mesh the whole body. I'll get a mesh. I'm not concerned about the mesh quality right now. Now is when I'm going to bring in my uh-oh moment. I'm going to bring back my solid, and this is where I'm going to realize I forgot something. I'm already in the meshing part. Normally, this might be a problem for me because I'm probably going to have to remesh or delete a mesh or, do a lot of work to get beyond this moment. In MSC Apex, because of the generative nature of the product, I'm simply going to go in. I'm going to create a mid-surface for the little flange, and we'll go ahead and mesh that flange. And that's got a mesh on it. And we can see that it's still disconnected. So let's go back to our edge and vertex drag tool, and we'll simply drag this edge to this flange and just watch that flange highlighted. It's okay that it's already meshed. Boom. It automatically made the mesh congruent, automatically stitched the geometry, and I'll do the same here as well. Okay? So I've now integrated that flange. That was my uh-oh moment. That was what I forgot. Or maybe that is, once again, we've gotten to the end of the process and we need to fix something so it'll pass. Maybe that represented that moment. If you have a tool that lets you work on the geometry and the mesh simultaneously, a lot of possibilities open up. And one of the ones that honestly excites me quite a bit is the fact that a lot of times your element quality tells you a lot about the quality of your geometry. So I'll do a quick element quality here, and I'll just kind of zoom in on one specific area. I can see that I have an element that has poor quality, and the reason it has poor quality is there's a little sliver, a little short edge, kind of a remnant of some of the geometry operations that I was doing. Maybe I wasn't paying as close attention as I should. Not a problem. I'll simply take the vertex, I'll drag it over, I fix the problem, the mesh automatically updates. Okay? Perhaps I'm at a point in the process where I look and I see that I've got some small holes that I really didn't want to include. I maybe wanted to actually defeature them originally. We have some very strong defeaturing tools. I will show those momentarily. But in terms of defeaturing, I can also, for simple things like these holes, I can just use the edge and vertex drag tool. So I can just simply drag that edge, get rid of the holes. Here's sort of an outside fillet, an outside round. I'll simplify. A lot of work that we do is idealization, and idealization is oftentimes simplifying the geometry. Here's a little lip. Maybe I don't want that in my simplified version. I'll just drag the vertex down. Notice how the mesh is automatically updating every time I make a change to the geometry. I'm not having to do any remeshing. That's happening automatically. Now, here's an interesting area. I have a poor mesh in this area right now. Let's look at fixing that. I actually have what appears to be sort of a fillet. It's not really a fillet. It's really just a long edge that's got a crook in it. So let's actually fix that. And let's do some simplification. So I'm going to add a vertex there. By adding that vertex, I can now move that vertex. And I'll move that vertex over to here. I'll look at my guideline, and presto, I've squared that off now. I got rid of a detail that I may not need in my analysis. Okay? I know a lot of times people spend a lot of time trying to get the mesh they want, especially in the area of interest. So I'm actually going to come in here. Maybe I want to automatically refine the mesh in this area, and I'm going to do that by maybe introducing some splits. Because if I introduce some splits, I can actually go in and use different mesh characteristics in different areas of the part. So once again, as I introduce the splits, the mesh automatically updates, automatically congruent. If I don't like what I did, if I'm playing what if, and we all play the what if game a lot, it's honestly probably more popular than soccer. I can quickly undo or I can quickly redo to go back. Okay? So let's look real quickly at some FEM editing tools that we have. We'll just do one real quick. We can totally move nodes around if I want to move a node around, maybe for a fastener location. Once again, we get feedback. This is an okay location. That's a bad idea, so don't do that. So we can move nodes around. Also, I know a lot of people will want to refine the mesh locally in stress areas by maybe adjusting the mesh seed. So I will increase the seed in that area, and I'll simply copy that down. to there. So we've got a pretty good looking mesh here. Got some washers around most of my holes. So let's actually go in and quickly create a material and assign that. So we'll create our material. My units are currently in metric. I'm going to enter in. I'm in Atlanta, Georgia, so I'm an English units guy. So I'm going to enter in my elastic modulus as 10e to the 6 psi. But Apex is going to automatically convert that to megapascals for me, and that's actually a good thing because I don't think I could do that conversion in my head. So let's quickly assign the material to our part. It shows up in our model browser tree there. As for thicknesses, let's do the thicknesses automatically. So we're simply going to use our automatic thickness tool where we're going to map the thickness from the solid to the shell that we have. So I'm simply going to pick my elements, and I'm going to pick my solid, and we've applied thicknesses here. And we graphically, these are not solid elements. This is just a graphical representation of the different thickness areas. Notice that my mid-surface was not always at the middle, okay, because I had lots of different thicknesses. And, you know, I could have arrived at mid-surfaces at the middle if I approached the problem slightly differently. But I can quickly review what the thickness and the offset is in each of these individual regions, okay? And I can also change it because we know that engineers are, once again, all about playing the what-if game. So maybe I want this flange to be one thickness now. Maybe I don't want it to be this thinner area. So I'll just quickly come in. I'll change my thickness, and I'll change my offset, and voila, the model is updated now. I'm ready for the analysis that I might want to do. So let's do one other thing real quick in our just remaining moments here. I'm going to shift gears from this mid-surface representation, and I'm actually going to do a different model now. So let's look at a different model. This is a small bulkhead, and we're going to look at a solid mesh on this particular bulkhead as opposed to a mid-surface mesh. And the first thing I want to illustrate real quickly are some defeaturing tools that we have in Apex. We can defeature solids or shells. We can defeature onesie twosie, which is what I'm currently doing, where I'm just going to pick, like, you know, in this case, pick the fillet, got rid of the whole fillet in that pocket. So we can do them one at a time if we want to. We can also do them a bunch at a time. All right, so we'll pick our entire solid. I get a nice little graphical range bar over here that I can directly interact with to isolate the fillets, in this case, that I'm interested in removing. And in this case, I want to remove the fillets between the flanges and the web area. So I'll just keep interacting with the range until I just basically see blue in the areas that I'm interested in removing. I want to keep these guys here. I'll select them from the graphical from the range bar, and I'll defeature, and they are gone. Okay, I can now come in and mesh this part, and so we'll just simply mesh it. And now we'll play the what-if game, which once again is, I think, more popular than soccer. So we'll come in here, and let's just pretend for a minute that we've analyzed this, and we feel that we need some extra reinforcement in this area. So let's add some reinforcement. And this, once again, will illustrate the generative nature of Apex, because even though it's meshed, that's not going to stop me. I'm going to fix this. So let's go in, and I will use our sketch tool, and I will sketch directly on the solid here. And let's change our grid spacing just a little bit. And I will simply sketch the outline. I can enter in exact dimensions if I want to, but I'm just going to sketch the outline of the flange that I'm about to create. And now I will use the push-pull tool. And the push-pull tool is to solids what the edge and vertex drag tool is to surfaces. So it's just simply going to allow me, I can enter a dimension, or I can drag the push-pull manipulator, and by pulling up on that manipulator, I've added a, quote, thickness or height to that flange. I can now either continue to do push-pull operations using the push-pull manipulator, or I can do some up-to operations where I want this face to be up to this face. And notice that the new little section that I have created it's automatically part of the solid that I have. It's automatically meshed and as part of the solid. It's part of it. It's not a separate solid. It's actually already been booleaned in. So I've quickly added in an additional flange using the up to operations to make it a part of my solid. The push-pull tool is also very useful. Although we have powerful defeaturing tools, the push-pull tool is also very useful. I can come in here and close up this hole, for instance, by taking that face, dragging that through. That hole is gone. In addition to operating on the faces of, say, a solid, the push-pull can also operate on the edges of the solid and actually allow me to create a fillet if I want to. If I want to reintegrate a fillet into my model. A lot of times you actually want a particular mesh on a particular area, and for that we have feature-based meshing. So I can quickly come in and say that on fillets or chamfers, washers around holes, I can define the mesh pattern that I want around these common geometric features. In the case of a fillet, I might actually say that, you know what, that the elements around the circumference there or along the face of the fillet, maybe instead of it being automatically calculated, maybe I want 3 elements. Okay, we'll go back to our solid mesh and we will enable feature-based meshing. We'll pick our solid, the mesh will update, and we'll have 3 elements across the face of the fillet as opposed to 2. And there's more that I could say, but in the interest of time, because I am running out of time, I'm going to kind of stop the demonstration. And there's going to be more of these type of presentations coming up in the weeks ahead. So you'll get to see more of MSC Apex Modeler. And you may probably want to get your hands on it because it's a lot of fun to use.